Hello. So this is problem section 832 Actex and SOA problem. It says let T1 and T2 represent the lifetimes in hours of two linked components in an electronic device. It says the joint density function of T1 and T2 is uniform over the defined region by this. And it gave us the defined region. And this is really important. Where L is a positive constant. Well, of course it has to be positive, right? We want it to be positive. Determine the expected value of the sum. The expected value of the sum of T1 squared, T2 squared. And I kept getting this particular one wrong because I kept on thinking, oh, they want me to sum S1, S2 and square it. No. What they said is that they wanted to have T1 squared plus T2 squared. So be careful with the reading and interpreting what they really want. It says, and I'll read it again, determine the expected value of the sum, which is crazy, so sum them up, of the square of T1 and T2. And so when they said it like that, that's what they expected. So here we go. So, well, that is basically, I need this T1 squared plus T2 squared over some joint distribution of T1 and T2, right? Wow. Of course, exactly. What is that region though? What is that? So we have to look at here, and it says this is defined over its uniform. And we'll call this T1, sorry, and this is T2. And we see that they're equal. And this is because they have both here, they're equal. It's called T2 is equal to T1. And that we're looking for the region where T2 is under L. We'll call this L. And this is L here on their part. So we're looking for this region right here. This triangle right here. Which means that the region, because it's uniform, is L, which is L squared over 2. Right? Half times the length and the length. Length here, because they're equal. Okay, so let's do that. That'll be T1 squared plus T2 squared, L2, 2. Let's do T1 first, D2 second. So, T1. Here's T1 here. Goes from here to there, which would be 0. T1 is going to equal T2. Goes from here to there. And then that T2 will go from 0 to L. Right? Right. Alright. This right here is nothing but a constant. We're going to throw that out so we don't have to deal with it again for a while. Okay? So we're going to integrate T1. So we're going to add 1 here. We did. We're going to add 1 here. We did. Okay? T1 is going to be swapped out with T2. And you see how slow I took that? Got to. then we're just left with L2 over 2, integrate 0 to L2 is equal to L of 4, 3, T2, 3. Because we got one whole one here, and we just add one sliver. Correct. D, T, T. All this calculus stuff, man. All these little things. But it's better to take our time and get it right the first time, and then spending minutes on the test and we miss it. Take your time and let's do it right. So now we have to integrate this. This is going to go to a 4. That 4 goes away. It goes right to a 3. 0. Where T2 is going to be counted as L. Oh, I know I did something wrong now. I just don't know what it was. What was it? Ah. Yes. I know exactly what I did wrong. Alright. I'm not going to redo this problem. Remember, uniform 1 over the area. So this actually is 2 over L2. 1 over the area. So all of this should be changed to 2 over L2. I'm going to switch it down here so I don't have to redo it. I don't mind if I messed up, but it should look like this. Voila. There we go. 2/3 L2. Answer C. So, where did I mess up? Uniform, constant. 1 over the area. 1 over the area. I got the area. I just didn't put 1 over the area. Thus, that changes this to 1 over that. It flips it right, and everything else stays the same, and then you get the right answer. 1 over the area. Still working on it.